Hello, Namaskar and welcome. Once again, we are going to start a series of lectures on chi-square test, and this time we are with a test of independence of attributes or variables, popularly known as the cases with contingency table. And in this case, we are going to discuss two main points. One is learning to prepare the contingency table from a managerial problem, and number two is chi-square test after preparing the contingency table with observed frequencies as well as expected frequencies. That means in learning the process of preparing contingency table, we shall discuss again 2 points. One is how to fit the statistics available from the question or problem or the managerial problem into a contingency table, and then how to calculate expected frequencies. We are starting with a case in which we shall prepare a contingency table of 2 by 2 only. That means with 2 columns and 2 rows. Let's first discuss the problem. Since the size of the problem is very small, I have preferred to write it on the board itself. Otherwise, mostly I am not able to write the question on table. Many of you many a times request me, but it is not possible. Yeah. In a certain sample of 2000 individuals in a city, a sample was made and 2000 individuals were covered under the survey. In a certain sample of 2000 individuals in a city, 1400 individuals are consumers of tea. Out of 2000, 1400 are consumers of tea. 1400 consume tea. That means remaining 600 don't consume tea. This is the interpretation of this question. Out of 1000 individuals aged 18 or above, again, out of 2000 individuals covered under the survey, 1800 individuals aged 18 or above. That means 200 were not 18 or above. So we can say that remaining 200 are less than 18 years of age. 1236, that means out of these 1800, 1236 consume tea. Test whether there is any significant difference in consumption of tea among the individuals aged 18 or above and below 18 years. Yes, this is the main thing. Okay, let's prepare the contingency table. So far as the attributes or variables are concerned, we have two sets. One is very clear, individuals aged 18 or above, and the second group is individual below 18. So we need to prepare either 2 columns or 2 rows for these two attributes or for these two variables. Okay, now first variable is age. Another is consumption of tea. There are 2 kinds of individuals, consuming tea and not consuming tea. So another attribute is consumption of tea, and there can be again 2 rows or 2 columns. One is consuming tea and another is not consuming tea. In this way, we have 2 columns and 2 rows on the basis of the having the characteristic and not having the characteristic. Those who have already studied the topic of association of attributes will find this something easier. But others who have not studied that chapter, don't worry. We are discussing, or we are going to discuss everything. So the 2 groups, 18 or above and below 18. Yes, 2 columns. Another, say, characteristic, consuming tea and not consuming tea. Again 2 rows. So this is called 2 by 2 contingency table. Technically this is called 2 by 2 contingency table. In a certain sample of 2000 individuals in a city, that means total number of individuals covered under this survey was 2000. In no circumstances the total can exceed 2000. So grand total of the contingency table comes to 2000. in a certain sample of 2000 individuals in a city, 1400 individuals are consumers of tea. That means out of these 2000, 1400 are consumers of tea or 1400 are consuming tea. So total of the persons irrespective of age consuming tea is 1400. Out of 1000 individuals aged 18 or above, that means these 1800 are out of these 2000, but the characteristic is age 18 or above. So the total of the individuals aged 18 or above, irrespective of the fact whether they consume tea or not, is 1800. Out of 1800 individuals aged 18 or above, 1236 consume tea. Yes, this is something like intersection. Age 18 or above and consuming tea. The characteristic, first characteristic or first attribute, aged 18 or above, and another is consuming tea. So this is something like point of intersection. Simultaneous happening of two events like that. As those who have studied the chapter of probability with the help of my lectures should be well aware that the cases with contingency table showing joint events and marginal events, we had already discussed. This is not very much different from that point. Out of 1800 individuals aged 18 or above, 1236 consume tea. Test whether there is any significant difference in consumption of tea among individuals aged 18 or above and below 18. Okay. Now first of all our target is to complete this contingency table. See, from the question we have say incomplete contingency table available. Grand total, total of the characteristic consuming tea, total of the characteristic age 18 or above. Now we need to find out the remaining empty values in remaining empty boxes. Yes, in these four cells on the upper side I am going to write the observed frequency. That means on the basis of this data. Then we shall find out the expected frequencies and write them in the same cell but below the observed frequency. First of all, how to find out the remaining observed frequencies? It is very much easy in the case of 2 by 2 contingency table. Since we have gap of only one cell on every side, we can find out just as difference. Yes, let's find out. Here the total is 1400 and this cell shows 1236. So the remaining amount should be 164. That is 1400 total number of persons consuming tea, and out of which 1236 are 18 or above. So remaining 164, I am very sorry. Remaining 164 must be the persons below 18. Similarly, if total number of individuals 2000 and out of which 1400 consume tea, remaining 600 don't consume tea. Same way, total number of individuals 2000 out of which 1800 are 18 or above, that means remaining 200 are below 18 years of age. Yes, just to show what we have found, I am writing all these in circle or box. You can use the sign of box also. This is nothing but to highlight that these amounts or these numbers are actually found by us after writing the data available from the question. Okay, now what? We can find these two as gap also. 1800 minus 1236 is the difference. That will be 564. That is the number of individuals aged 18 or above and not consuming tea. Similarly, here it must be 36. Yes. 200 minus 164, 36, 600 minus 564, 36. This shows that we have found all the values correctly. Now what? Now we need to find out the expected frequencies in these four cells. How to find out? That is very much easy. See, this is the formula. Expected frequency equals to, expected frequency for any cell equals to row total multiplied by column total divided by grand total of the table. Let's find out the expected frequency for this observed frequency 1236. Row total means the total of the row in which 1236 is there. That means total of these row. It is 1400. Multiplied by column total. What do you mean by column total? Total of the column in which 1236 is there. That means column of this total is 1800. Divided by grand total means grand total of the whole table. It comes to 1260. Let me use the pen of another color. 1260. Okay, now we have two alternatives, either to use the same formula for the remaining three expected frequencies, to find the remaining three expected frequencies, or again we can find out all these three frequencies as the, say, balancing amount or missing amount, because the totals are going to remain constant. Whether it is, say, a table with observed frequency or with expected frequencies, the total will remain same because that is reality. Survey of 2000 individuals was made, out of which 1400 are consumers of tea, out of which 1800 are 18 or above, 200 below 18, 600 not consuming tea. These are also actually, say, real numbers, real values out of 2000. But we need to find out expected frequency for our purpose of testing of hypothesis. Okay. So 1400 minus 1260, the gap is 140. 1800 minus 1250, the gap is 540. 600 minus 540, the gap is 60. So now we have all the four expected frequencies. So this is the contingency table with observed as well as expected frequencies. The expected frequencies I have written with red color pen. You can also prepare two separate contingency tables, one for observed frequencies and another for expected frequencies. But I prefer to suggest to prepare the contingency table in this way, because in this way we can correctly maintain the pair of observed and expected frequency to calculate the chi-square. Okay, now what? Now second part, testing of hypothesis. The hypothesis is actually readily available from the question. Test whether there is any significant difference in consumption of tea among the individuals aged 18 or above and below 18 years. First of all, basics. The null hypothesis is always about no difference. So simply the null hypothesis can be there is no significant difference in consumption of tea among the individuals aged 18 or above and below 18. Okay. Now the words test of independence. With that, the words of null hypothesis written in this way say seem not to be matching. It's not like that. The interpretation with reference to independence or not for this kind of null hypothesis is, see, I am repeating null hypothesis, there is no significant difference in consumption of tea among the individuals aged 18 or above and below 18. Why should we write this kind of words? This is a real case, this is our actual case. The same wordings are in the question. and we are just following the basic rule, no difference in case of null hypothesis. But so far as the independence is concerned, the interpretation of the null hypothesis can be consumption of T is independent of age. Whatever age of individual is, whether individual is 18 or above or below 18, no difference, no significant difference in the characteristic of consumption of T is there. That kind of interpretation can be there for the hypothesis given in the question. Similarly, the alternative hypothesis is counter argument against the null hypothesis, and it is always exactly opposite to the null hypothesis. In null hypothesis there is no significant difference, so in alternative hypothesis there is a significant difference in consumption of T among the individuals age 18 or above and below 18. The interpretation of this alternative hypothesis can be consumption of T is not independent of age. That means the age affects the characteristic of consuming T or not to consume T. Yes. Think over this. I suggest you to write these wordings of hypothesis also, and for your ready reference I am going to write all these things with the video of the lecture, so please don't forget to click show more. Yes, okay. Now what? The calculation of chi-square first of all. Okay. How to calculate chi-square? Very easy. O stands for observed frequencies. That means frequencies, say real frequencies, result of this survey. Yes. And E stands for expected frequencies. There are so many ways of writing all these things. I am not going to repeat other. The important thing is, don't forget to maintain the pair of observed and expected frequency of the cell. If you write 1236 here, you need to write 1260 with it. This pair must be maintained. Don't forget it. Similarly, 164 and 140, you can write in, say, columnar form also or in row form also, but don't forget to maintain the pair. 564 and 540 and 36 and 60. Let's check. 1236, 1236, 164, 564, 36. 1260, 140, 540 and 60. Okay. The total must be 2000. Just check it. It is not compulsory to write, but as a checkpoint, it is necessary. Yes, observed minus expected. Yeah, there is difference of O minus E, minus 24 plus 24 plus 24 minus 24. And O minus E the whole square. That means square of 24, 576. Yes, now somewhat technical. Try to use the calculator efficiently. Yeah, O minus E the whole square divided by E. 576 divided by 1260. It comes to 0.457. Similarly, O minus E the whole square divided by E. 576 divided by 140. It comes to 4.114. O minus E the whole square divided by E. 576 divided by 540. It comes to 1.067. And the last is 576 divided by 60. It comes to 9.6. And summation 15.238. This is called chi-square. That means sigma O minus E the whole square divided by E is the formula of chi-square. But it is advisable to find out the chi-square in this kind of tabular form to save ourselves from making any kind of, say, arithmetical or calculation related mistakes. Now what? Okay, level of significance, I forgot to write it. It has been given as 5%. That means alpha is 0.05, and chi-square test of independence is always one-tailed test, so no alpha by 2. Yes, level of significance. Yes, most important thing, degrees of freedom equals to number of columns minus 1 multiplied by number of rows minus 1. Number of columns 2, 18 or above and below 18 minus 1 into number of columns 2 consuming T and not consuming T, that is 2 minus 1. So it is 1 multiplied by 1 equals to 1. Degrees of freedom only 1. On the basis of degrees of freedom and alpha, we can find out now the critical value. Yes, we have already discussed how to find out the critical value of chi-square when we were discussing the chi-square test of single population variance, so I am not going to repeat it. Yes, okay, and it is 3.841. And now the similar thing, chi-square calculated is 15.238, chi-square critical is 3.841, and now we know that what to do, compare these two, and we can see that calculated value of chi-square is greater than the critical value. That means the null hypothesis is rejected. If null hypothesis is rejected, alternative hypothesis becomes our conclusion. So the conclusion will be, I suggest you to write both the things first. Repeat the alternative hypothesis as conclusion. There is a significant difference in consumption of tea among the individuals aged 18 or above and below 18. Looking to the scarcity of space, I am not going to write it, so I am actually speaking it twice or more than twice. The conclusion will be, there is a significant difference in consumption of tea among the individuals aged 18 or above and below 18, because the null hypothesis is rejected. The calculated value of chi-square is greater than the critical value. Okay, right, further, that means what we had discussed at the time of interpreting the hypothesis is the consumption of tea is not independent of age. The interpretation of our conclusion that there is a significant difference in consumption of tea means it is dependent on age, consuming tea and not consuming tea. In our society, particularly in India, it is a reality. Mostly the parents don't prefer to offer or to allow their children drinking tea. They normally drink plain milk or milk with some additional powders or malt, etc. But mostly in our society, people start to drink tea at the advanced age, and this is actually matching with that reality. So this was quite a longer lecture, but I think this lecture will prove to be very useful for all of you to learn how to prepare a contingency table from a managerial problem, how to find out expected frequencies, how to write the hypothesis as well as how to interpret the hypothesis and how to find out the chi-square with the help of this kind of table, and how to perform the test of hypothesis. So don't forget to like this lecture and don't forget to subscribe my YouTube channel, PRASHANTPUAAR. That's it. Thank you.